Hi everyone, we're going to go ahead and get started on today's practice with writing and solving systems of equations. You should have this worksheet in front of you. It is double-sided. On this video, I'm going to go ahead and do some of the examples on the writing and solving systems, this side here. And then I'm going to do some examples on the back side of the paper as well. And the rest of it will be class time, where you're using class time to complete this worksheet. Whatever you don't complete in class is then homework. Okay? All right, I did make a mistake on number 1 where it says 785 tickets. Could you please replace that with 784? Okay. So a movie theater charges $5 for an adult ticket and $3 for a child ticket. Okay. One Saturday, the theater sold 784 tickets. Again, make sure you change that to 784, please, for $3,280. How many child's tickets were sold and adult tickets were sold? Okay. So before we can start writing a system of equations, we have to realize that we're talking about two items in this scenario. So we will have two variables representing that information. So with X, I'm going to use X to represent the child's ticket. And I'm going to use Y to represent the adult ticket. To help me determine which equations I'm going to write, I'm going to use that information they gave me about totals, because the totals is going to help me see what I am actually looking for. So the first total that I'm looking for is the total number of tickets. And the second total that I'm looking for is the total money. So one equation is going to have to do with the number of tickets. The other equation is going to have to deal with the amount of money. Okay. So let's talk about that first one. Total number of tickets. Well, I've had some child tickets, and I'm going to add that to some adult tickets, and that's going to give me the total tickets of 784. So there's my first equation in my system. The second one is I'm talking about the total cost. So each child ticket costs $3. So 3 times however many child's tickets were sold, plus $5 times the total number of adult tickets that were sold. This is what we don't know yet. And the total money raised was $3,280. Okay. Now that we've got the system of equations, we can go ahead and begin looking at using elimination. Now, when I'm using elimination, remember that the coefficients need to be the same coefficient value, and they need to be opposite operators or opposite signs. So the x's right now, I have a 1x and a 3x. With the 5's, I have a 1y and a 5y. So I'm going to go ahead and change that first equation, and I'm going to multiply it by -3. Doing that allows the x's to be eliminated, okay, because then I'll have a -3x and a positive 3x. So let's go ahead and rewrite those equations, or rewrite the first one. So -3 times x gives me -3x. -3 times y gives me -3y. And because we are changing the entire equation, we also have to do -3 times 784. Okay, so that would give us 2,352. The second equation we did not need to change because we're trying to eliminate those x's. So we have 3x plus 5y is equal to 3,280. And I just seen that I forgot my negative. So let me put that in a different color. It should be negative 2,352. Okay, so now we can go ahead and combine like terms so that we can eliminate. We were trying to eliminate the x's, and those are now eliminated. So then negative 3y plus 5y leaves us with 2y, and 2,352 minus 3,200, or plus, it's negative. That would give us positive 928. Okay. Divide both sides by 2. And we get y is equal to 464. So the Y represents the adult tickets, so they've sold 464 adult tickets. How can we find out how many children's tickets they sold? So we can take that Y value and plug it back into either of our original equations. So I'm going to go ahead with x plus y equals 784 because that one looks easier to me. Okay, less math involved where we're having to multiply or use any distribution. So we're going to have x plus 464 equals 784. Go ahead and subtract 464 from both sides of the equal sign. Okay, and with this one, we get x equals 320. Okay, now once we've got what y equals and what x equals, because this is a word problem, I want you to answer it in word form. So here when the question says how many adult tickets and how many child tickets were sold, there was 320 child tickets sold. And 464 adult tickets sold. Again, given a word problem, you should answer in word formation. Okay? All right, I'm going to leave number 2 for you. That one is similar to this one. All right, and let's go on to number 3. All right, since my uncle's farm seemed to be overrun with chickens and dogs, I asked him how many of each he had. Being a puzzler as well as a farmer, my uncle that has dogs and chickens had a total of 148 legs and 60 heads. How many dogs and how many chickens does my uncle have on the farm? Okay. All right, so let's go through. He's got chickens. He's got dogs. Okay. He said that they have a total of 148 legs and 60 heads. How many dogs and chickens? So how many dogs and how many chickens? Okay. Well, I have my variables here, C and D. So I have chickens and we have dogs. So what totals do we know? Well, we know the total legs and we know the total heads. All right, so let's go ahead and come up with our two equations. Well, the first one, when we're talking about legs, how many legs does a chicken have? Well, a chicken has 2 legs. So 2 legs for however many chickens there are. And we're going to add that to dogs have 4 legs. So 4 legs times however many dogs there are. And that gives us 148 total legs on the farm. Now, when it comes to the heads, well, each chicken has 1 head, and each dog has 1 head. So the total heads would be 60. Okay. Now that we've got those 2 equations to make up our system, we can use elimination. We've got to decide whether we're going to eliminate the chickens or the dogs for this first round. I'm going to go ahead and just go with the chickens. So I'm going to multiply this second equation by -2. So my first equation is going to stay the same. 2c plus 4d equals 148. My second equation is -2c, -2d, and -120. All right, the c's get eliminated. 4d minus 2d is 2d equals 148 minus 120 gives me 28. Divide both sides by 2 and we get d equals 14. So there are 14 dogs on his property. Now take that value of 14 and plug that back into either equation. So I'm going to go ahead and use c plus d equals 60. So c plus 14 equals 60. Subtract 14 from each side. And c equals 46. Okay. So again, to answer this in word form, there are 14 dogs and 46 chickens on the farm. Okay. All right, last one that I'm going to do is number 5. The sum of 2 numbers is 92 and their difference is 20. Find the 2 numbers. All right, so x would represent my first number. Y is going to represent my second number. Okay, and their sum, so their sum is 92, so that's 1 total. And their difference, which means subtract, is 20. Okay. So first I'm going to add those 2 numbers. So I have x plus y is going to equal 92. But when I take those same two numbers and I subtract them, their difference is 20. Okay, so there's my system of equations. I can see here that the y's have the same coefficient of 1. They are opposite operators, so I'm going to go ahead and eliminate the y's. So x plus x gives me 2x equals 92 plus 20 gives me 112. Divide both sides by 2. And x equals 56. Okay. Right, now I'm going to take that x value and plug it into either one of the equations. So I'm going to go ahead and go with x plus y equals 52. Oh, 92. So I have x, nope, not x, 56 plus y equals 92. So I'm going to subtract 56 from both sides to get y by itself. So 92 minus 56, and we get 36. Okay. The two numbers are 56 and 36. All right, I will see you in the next video.